All right, so let's start going over some examples on circuits. Okay, so from here you can see that the total resistance would equal uh, R1 plus R2 plus R3 because they're in series. On the second example, this is actually a combined, or actually not combined, but it's just a series circuit as well. It looks like it's parallel, but it's just series, right? So all we have to do is add all four resistors. 4 ohms plus 4 ohms plus 4 ohms equals 12 ohms. And you can see that because there's no option of that current doesn't have any options of where it's going. Now in this other case, we can see that all these resistors are in parallel, right? So it would equal 1 over 1 plus 1 over 2 plus 1 over 3 to the negative 1. Sorry that 1 is not here. Let me add it. There you go. Okay. And then if we actually put numbers on there, so this is how it would actually look. And when you do the math, it would equal to 2 ohms. Okay. So again, this is just a quick example for you to see how to figure out this equivalent resistance, because once you find that, then you can find the voltage and you can find the current. Okay, so let's do this example. You have a 60-volt battery and you have three resistors, a 4 ohm resistor that's in series with two resistors that are in parallel, 12 ohms and 6 ohms. So the first thing we have to do is we have to break it down. We have to simplify the circuit in order to find the equivalent resistance and the total current. So the first thing we would do, let me go a little slower, right, is you find the total or the equivalent resistance of those parallel circuits. So that's 1 over 12 plus 1 over 6 to the negative 1, and that would actually give you 4 ohms. So now we can redraw this this circuit, and what that gives you is that you have two 4 ohm resistors in circuit, right, in two 4 ohm resistors in series. So now we can just add those up, and we know that our total resistance is actually 4 or 8 ohms, right? So we can write that into our answer. So that's A. We know the total resistance, right? But now we got to find the total current. Well, we know that when resistors are in series, the current is the same. So total current equals 16 volts, which is what the battery is providing, and 8 ohms because that's our equivalent resistance, so they know that our current would be 2 amps. Okay, so let me see, give me a second. Now, if you wanted to find the voltage drop of each of these, then that'd be a little different, because you can come up here and actually say voltage here is voltage equals IR. So now we know the current, right? So that would be 0.2 times 4, and that equals 0.8 volts, right? So that means the rest of the volts have to drop in the next two resistors. Now, let's just talk a little bit about proportions now that I showed you how to work those problems. But let's remember that, let me back up a little bit. Voltage equals IR, current equals voltage over resistance. Just remember this from Ohm's law. And we know that current, okay, is if voltage goes up, current goes up. If voltage goes down, current goes down. So they're directly proportional to each other, current and voltage, okay? Resistance is inversely proportional to current. So if resistance goes up, current goes down. If resistance goes down, then the current goes up. Okay. And a quick example for proportion is if you have a current, okay, or current 1 that's just equals the voltage over R. We know that from our equation, and then you double the resistance. Then what that means is that the current would equal half of the original current, right? Because you're increasing the resistance, so that means you're lowering the current. Okay. If we're looking at power, then power we know is voltage square over R, or other variations that you guys have seen already, but they're proportional to each other. Same thing with resistance, they're inversely proportional. So if resistance goes down, power goes up. Okay, so power goes up. Okay, and if resistance goes up, power goes down. So with knowing that, we know that if resistance goes up, current goes down. So that, and power and current are directly proportional to each other. So if current goes down, power goes down. If resistance goes down, current goes up, so that means that power has to go up as well, okay? And this is just proportional, okay? They're proportional to each other. Power and current are directly proportional and inversely proportional to resistance. I hope this helped, and make sure you look for more resources and do your practice problems to be ready for your quizzes and exams.